Alright, hello everyone, how are you? I hope you guys in good condition. Alright, so now in this video we are going to learn new topic, which is chapter 9, solution of triangle. So basically from this title you already know that we are only going to talk about one shape, which is triangle only. Okay, so let's get started. Alright, so first thing we want to learn is sign rule. Okay, so let's watch this video.
So this chapter called Solution of Triangle. Purely with the chapter name, you should know this chapter only talk about one shape, triangle. But before I start, how a triangle look like? A triangle look like something like this. So they always have some alphabet when you use the formula, okay? And for triangle, right, they have three corners, right? So one of the side we call it A, one of the side we call it B, another side we call it C. Which one A, which one B, which one C doesn't matter. Just one A, one B, one C, okay? And then the A, opposite of the A, we always call it big A. Opposite of the B, we always call it big B. Opposite of the C, we always call it big C. So this is exactly later on you see all the alphabet, this is actually what they mean, okay?
According to sine rules, A, the side length here, divided by sine of this angle is equal to B, the side length of B, divided by sine this angle, and is equal to C divided by sine angle C. Okay, so we can actually invert them. You can write them become sine A over A is equal to sine B over B is equal to sine C over C. Normally, if the questions ask us to find side length, we will choose this one. If the questions ask us to find angle, we will choose this one. So this rule not only can be applied for acute angle triangle, it can be also applied for obtuse angle triangle, for example this one.
Okay, from the video, it is mentioned that we have two types of formula for sine rule, which is formula 1, A over sine A equal to B over sine B equal to C over sine C. And the other formula, we just let the denominator from the previous formula as numerator, and it becomes sine A over A equal to sine B over B equal to sine C over C. So the difference between these two formula is we use formula 1 when the question asks to find the length of side, and for formula 2 we use when the question asks for the value of an angle, okay, of a certain angle of the triangle. So we use formula 2 because this is more easier than formula 1 when we want to find the angle. Okay, so now let's look at on how to apply these two formula. Okay, in our syllabus, for sine rule we have two cases, where the first one is when we have two angles and one side unknown, and the second cases is when we have two sides and a non-angle are known. Alright, before I show you the example for both cases, let's watch this video where it explains what is the meaning of included angle and non-included angle.
But let's go talk about an included angle. So if I have an included angle, what an included angle means is an angle between two sides. All right, so we always talked about our side, side, side congruence. But now if we have side, angle, side, Malik, what that tells us is we have side, angle, side. So here's two examples of included angles. The reason why we call them included angles is because the angles are in between the two sides. Now, where it gets a little difficult for this is, let's pretend, let's do another triangle. And let's try to see if they're congruent by side, angle, side. So let's do side, angle, side. Or let's do side, angle, side. Okay? So, ladies and gentlemen, these two angles are not, or these two triangles are not congruent. Remember, if it's going to be side, angle, side, now these two have two sides, right? And let's say these two are equal. Right? It has two sides and it has an angle. You could say side, angle, side. Right? And you could say side, angle, side. Correct? Can you not say that? Yes. Just like we did here. Side, angle, side, side, angle, side. But do you notice how these are so nice and tight to each other? Right? Your angle is in between the two sides. So these are what we call included angles. Here, if I was going to do side, angle, side, I do side, I skip this angle, skip this side, and then I go to that angle. Well, therefore, you're skipping all those. It's not going to be included. Therefore, this is not, you cannot prove this with side, angle, side. You can also not go side, angle, side. All right? You can't skip over your angle if you're going to do a side, angle, side. You can't skip over another angle to try to do it. All right? So these would not be included angles.
All right, now. Okay, since you already understand what is a non-included angles, so let's see the example for case 1, which is two angles and one side are known. Okay, given the angle of BAC is equal to 97.51 degree, and angle for ACB is equal to 39.88 degree, and the length for BC is 5.5, and the question wants us to find the length of AB. So here is the diagram. As you can see, this is triangle ABC. Okay, from the question, angle BAC, where is BAC? BAC. So this is the angle for BAC. So it is equal to 97.51, and angle for ACB, ACB is equal to 39.88 degree. Okay, the length for BC is 5.5. All right, so the question wants us to find AB. So okay, from here, since we want to find the length of side, we use formula 1. Okay, so just substitute the information in the formula. All right, so this is the calculation. Okay, we know side is 5.5. Okay, so the opposite angle is 97.51. So we substitute in the formula 5.5 over sine 97.51 equal to, okay, this one we want to find AB. So AB, the opposite angle is 39.88. So we substitute, we have AB over sine 39.88. So just calculate. Okay, when you want to calculate, okay, use your calculator. Okay, 5.5 over sine 97.51, and then we multiply by sine 39.88. all right, so we get the 3.557. okay, so I just want two decimal places, so we have 3.56. okay, here we get 3.56. let's see if it's true. Yeah, it is true. So as you can see, when the answer is true, it will display here that AB is the 3.56. so excellent. Okay, so I hope you guys understand for the first example, and let's continue to case 2. Alright, where we have two sides and a non-angle. Alright, so as you can see, we have two sides. DF and FE are known, and the angle is 112. Since we want to find the angle of E. We use formula 2 since we want to find the angle. Okay, so this is the calculation for case 2. We have sine 112 and the opposite side is 3.64. Okay, so substitute, and is equal to sine E since we want to find angle E, and the opposite side is 1.47. So the answer for sine E here, let's calculate. So sine 11 and 12 is over 3.64 multiplied by 1.47, get 0.3744. Okay, so let's enter 0.3744. So in order to find angle E, only angle E, so we move sine to the right hand side, and it will become sine inverse 0.3744. Sine inverse 0.3778 44. So we get 21.99. So that's the answer. So you already finished for these two cases. Now let's continue on how to solve triangle involving ambiguous cases.
So let me explain a little bit about the ambiguous case for you first. Okay, let's look at this example. Let's say if the question tells you that we have a triangle ABC, AC is equal to 5 centimeters and BC is equal to 8.06 centimeters, and the angle CAB is equal to 53.13 degrees, for example. This length is longer than this one. So in this situation, there's only one triangle that we can form, which is this one. So this is not an ambiguous case. But sometimes, if let's say I change the shape a little bit. Okay, so now this become different side length and different angle. Now if the question gives you this length and this angle, there are actually two triangles you can form. One of them is this one, right? This is shorter than this one. In this case, we actually can form two triangles. Another triangle will be over here. ACD, you will notice that they have the same length, 8.94, 4.47, and this angle. Then you look at ADC, same thing, 8.94, 4.47, 26.57 degree. So in this situations, by following the given measurement, we can form two triangles, right? So this we call it ambiguous case. And you try to observe their relationship between the angle. Oops. So if let's say one of the triangle formed here, the angle here is 63.42 degree. So how about another triangle, which I means is ACD. So one of them is ACB, or you can say ABC, and then one is ACD. So you will notice that they have some relationship, right? If this is 63.43, here will be 63.43 as well. So if you want to get this angle, you just take 180 minus 63.43. So we have two triangles here. One is obtuse angle triangle, which is ADC, ACD. Another one is acute angle triangle, which is ABC. So remember their relationship of the angle, the relationship between this angle and this angle. If you get this angle, then you want to get the size of this angle will be very easy. You take 180 minus this one. Okay?
Hi, Assalamualaikum. I am Shamimi. Now it's my turn to explain to you about the second subtopic for this topic, which is cosine rule. So, similar to the sine rule, the concept of triangle in cosine rule are still the same. Okay, if this is the vertex B, then the opposite side will be B also. The difference is the vertex we will write in capital letter B, while the side we will write in small letter b. So if this is vertex A, then the opposite side right here will be side A. So moving on to this one. For any triangle ABC, the cosine rule stated that A square equals to B square plus C square minus 2BC cos A, or B square equals to A square plus C square minus 2AC cos B, or C square equals to A square plus B square minus 2AB cos C. So can you spot the difference here? When we want to use this one, when we want to use the second one, or the third one. So if you were to find the length A or angle at vertex A, you can use this one. Why? Because right here A square already be the subject, so it is easier for you to find directly find the side A. As for the angle, because if we were to find the angle at vertex A, we need to use this one, because cos A will appear if A square will be the subject. Okay, so similar to the second and third one, if you were to find side B, or you were to find angle at vertex B, then you use the second one. Okay, so the question here is the cosine rule true for all types of triangle? Yes, you can use this cosine rule for all type of triangle by angle. We have three types. The first one is acute triangle, right triangle, and obtuse triangle. So you can use for all those three types. To use cosine rule, there are two conditions, but we only need to comply either of this one. So for the first condition, if we are given the length of two sides and value of an included angle, so we can use cosine rule. Or in the triangle, we know all length of all sides in the triangle, and there is no value of angle that we know, so we also can use cosine rule. So let's look at the first diagram here. In this diagram, we can know the two sides, which is VU and VW. So an included angle, the included angle will be at V. Usually this condition will use if we were to find the length of UW, or in other words, we were to find the length of opposite side to the given angle. Okay, so the next example, the next diagram, we can know the three sides. All sides, the length of all sides are given in the diagram. Okay, so in this case, we also can use cosine rule. Usually, this case are used if we were to find one of the value of angle in the vertex. Okay, either X, Z, or Y. Now, let's move to the example for the first condition, which are two sides and an included angle are known. Here we have triangle MNO, and it is given MN equals to 5 and MO equals to 6, and the angle NMO is 55. Okay, so the angle at the vertex M here is the included angle. Okay, so just now I said usually for this condition we use it if we were to find the opposite side to the given angle. And look at the question. Find the value of NO. Yes, NO is opposite to M. Okay, so first you have to identify the name of the sides, like we have learned before. Opposite to a vertex M, this will be side M. We write in small letter. Okay, so opposite to vertex O will be small letter O, and opposite to vertex N will be small n. Okay, so here we already know the angle at the vertex M, the value of N, side N, and the value of side O. Okay, then we have to find M. if we were to find m, then we need to make m square as the subject. And for the cos, angle at the cos, we will use angle m. Okay, so this is the formula. M square equals to n square plus o square minus 2no cos m. Okay, so next what you need to do is just substitute the value. We know n, side n, we know side o, and we know angle m. So just substitute it. To find m, we have to eliminate the square. So to eliminate the square, we need to put the square root. Okay, we need to put the square root here. If we were to put the square root, the right hand side right here also have to put the square root. Okay, square root of m square, we will get m. That's why next step we will get like this. Okay, so then you calculate all of them, you will get m equals to 5.16. Next, let's look at the example for the second condition, which is 3 sides and no angle are known. Okay, in this diagram, we have triangle XYZ, and it is given XY is equals to 7, YZ equals to 6, and ZX equals to 4. So we already know the length of all sides in the triangle. Okay, so just now when we learned the theory, I mentioned that for this condition, usually we use if we were to find one of the angle. And the question here asks us to find the value of angle ZYX, which means we need to find the angle Y. Okay, so same step as the previous condition, we have to identify the sides first, the name of the sides. Okay, the opposite side to angle to vertex X is side X. We write it in small letter. The opposite side to the vertex Y will be small letter y, and the opposite side for vertex Z will be small letter Z. Okay, so now we were to find angle at vertex Y. So what will be our subject? X square, Y square, or Z square? We will use Y square because we have to find the angle at vertex Y. Okay, so y square equals to x square plus z square minus 2yz cos y. See, here we have cos y, which is the angle that we want to find. So we just have to substitute all the value that we already know, y, x, and z, side y, x, and z, just substitute it. Okay, to find y, we have to make cos y as the subject. So all of this we need to move it to the left hand side. So I just switch the position here. Okay, I just switch the position. Cos y equals to 4 square minus 6 square minus 7 square over negative 2 times 6 times 7. So if you calculate this one, you will get, okay, let's fill in here, we will get 0.82. Okay, so that is the value for cos y. We only want to find the y, angle of y. Okay, here we only want to find the y. So we have to move the cos to the right hand side. Okay, if we move the cos here, it will be cos inverse. Okay, cos inverse 0.82, we will get the answer for angle y is 34.92. Okay, so now let's check whether the answer that we get right here is true. Okay. Alright, so the computer generate for us, the answer will be 34.77. Since the computer have round off it to the hundredth for all the answer, then it is possible for us to get a bit different than the computer generate. Okay, so that is all for cosine rule. Thank you.
So today we are going to learn two more new methods that can help us to get the area of a triangle. So if you want to use this method, same thing, we have to add 1 or 2 in front of this. If we use side A and B, we need to use angle C, 1 or 2 A times B times side C. So if we use A and C, so this is A, this is C. Okay, we need to use angle B, A, C, side B. Okay, and I forgot to type another one. So how about if we use side length for B and C? Okay, same thing. We need to add 1 with 2, B, C. Then we have to use the angle A, side angle. Oops, okay, let me write again. Side angle A. Okay, now let's try to use this method to help us to get the area of this right angle triangle. Okay, so this formula we call it as Heron formula. So you will see S here. S is the semi-perimeters. Means that you want to take the perimeters of this triangle divided by 2. Okay, so if we use this formula, we need to find S first. Perimeters for this triangle, I think it should be no problem. Take this, just find the sum of all the side length of this triangle, which is equal to 3 plus 4 plus 5. Okay, if you don't want to write the units, it's okay. And then we have to divide it by 2 because this is semi-perimeters. Okay, so you will get 6. Okay, 6 centimeters. Okay, so if you want to use this formula, it's actually very easy. Area of triangle ABC. Okay, let's try. We should be able to get exactly the same answer as this one, which is equal to 6 square centimeters. Okay, so you open, write square root first. Okay, how about I write 3 parentheses first? Now I have 3 sides, right? 3 parentheses. Okay, so S is the semi-perimeters of this right angle triangle, which is equal to 6. And then we need to take this semi-perimeters minus the side length for minus A, which is 6 minus 4 times 6 minus 3 times 6 minus 5. And then we have to square root this whole thing. Okay, let's check, see whether we can get this the same answer. So this is 6, and this is 2, this is 3, and this is 1. Square root it. Okay, here you will be able to get 36. Square root 36 is equal to 6. Okay, we still get the same answer.
Hello everyone, since all of you have watched the previous video on the theory for the area of triangle, okay, let's recap a bit on the area of triangle. Okay, you can, the left side is the general formula for solving the area of triangle. Okay, as you can see, the formula, you can use the formula when we are given the 2 lengths of sides of the triangle, as well as included an angle. Okay, for example, on this triangle below here, you can see an angle as well as 2 sides of the triangle. It is given with the value, and then you can use this general formula of the triangle. Okay, you have to find area of triangle ABC equal to 1 over 2 small letter of A and the small letter of B. Okay, this small letter means that it is, you can see on the previous video, it is said that the opposite of the angle A here is a small letter of A. And then the small letter of B, it comes from the opposite of the angle of capital B here. Okay, so this one is a small letter of B. Okay, sign C. Okay, the sign C, seeing the capital C is 51 degree. And then you can see, okay, the answer is area of triangle ABC is equal to 1 over 2 A. Previously we said it is 5, right? 5 times the small letter of B is 3, and then sine C. C is 51 degree. And then after that, you use solve it by using a scientific calculator, and you will get the answer is 55.82 centimeter square. Okay, and the other formula that you can use to solve for the area of the triangle is the Heron's formula. Okay, so to use the Heron's formula, the first step is find the semi-perimeter. Find the semi-perimeter S. The small letter S, it is means semi-perimeter of the triangle. You can see that's why we need to use this formula, Heron's formula, when the question given have the length of 3 sides of the triangle. Okay, for example, on this example of the triangle, you can see all of the sides of the triangle have its own value. So you just sum up all of the perimeter of the given perimeter and divide it by 2. Okay, then you will get the answer for value of S. Okay, then the step 2 is what you need to do is substitute the value of S, and then substitute the value of all the 3 sides of the triangle inside the Heron's formula. Okay, for example, let's take a look on the below here. Let's take a look on the example in solving the area of triangle by using the Heron's formula. Okay, please make sure the triangle given have its own value, the 3 sides of the triangle, and then find the semi-perimeter, which you have to sum up all the value of the sides of the triangle. 5 plus 3 plus 3.89 and divided by 2. Then you will get the answer. So please use your scientific calculator to find the answer. Okay, now let's recheck the answer. Okay, so the semi-perimeter is 5.95. Okay, so right here, 5.95. And then find the area of ABC. Okay, please remember the formula of Heron's formula. Okay, this one is S, semi-perimeter. This one also S. This one also semi-perimeter. And you can see that 5, 3, and 3.89 is the value of the sides of the triangle, sorry. AB, and this one is C. So you substitute all of the value of S, A, B, and C inside the Heron's formula. Then you will get the answer. So let's recheck on the answer. Let's recheck. So it is 5.85. Okay, 5.85. So 5.85 centimeter cube. Then you get the answer. And now let's proceed with the activity. Okay, let's find the area of the custom triangle. Okay, it's very interesting since I'm using GeoGebra. You can see you can custom your own triangle length by dragging the slider. So it is very interesting, right? Okay, okay, you can slide any value that you want. Okay, you can see it also change your triangle from the small one and the big. Okay, you can play your slider like this. So you can check, let's say the value of V here, small letter of V is 3, and then slide your slider here. Let's say T, we want value, okay. Oops, I want to. Oh, okay, let's say it is 2.5. Okay. So let's use the general formula of area. Okay. Don't forget about the formula just now. 1/2 times with, you can see here, there is an angle here for 46.56 degree, and then it is given with the value of the sides of the triangle. You can see 1/2 times with U. U is 3.29 times with V, and V is 3 sine 46.56. The T is the angle of the triangle. And then use your own scientific calculator and you will get 3.59 centimeter cube. Okay? And then let's take a look on the Heron's formula. Okay, let's take a look on the Heron's formula. You can see that the Heron's formula, you have to solve for the semi-perimeter first. Okay, S equal to T plus with U plus with V. Okay, T plus U plus V. Okay, and then divided by 2. You will get 4.4. Okay, and then substitute the value of S, T, U, and V. Okay, and then after you solve, then use your scientific calculator to get an answer. So the answer is 3.59 centimeter cube. Okay, so what you can see here, do you recognize any similarity or difference by using both of this formula? Okay, for the Heron's formula, you can see the answer is 3.59 centimeter square, and the general formula of the area is the 3.59 centimeter square. So you can use both of this formula and you will get the same answer. But you have to choose which formula that you are going to use, since it has its own conditions. Okay, so don't be careless on that. Okay, so I hope all of the students will understand on this subtopic, area of the triangle.
Hello everyone! Okay, this session will focus on the application of sine rule, cosine rule, and also area of triangle. Do you understand all the explanation and videos provided previously regarding the solution of triangle? Well, I hope you are. But before we start, let's do a quick recap about all the formulas involved in this topic, which is sine rule, cosine rules, as well as the area of a triangle. Firstly, sine rule, or also known as the law of sines, its formula is sine A over A equal to sine B over B equal to sine C over C, or you may turn the whole thing over and write it as A over sine A equal to B over sine B equal to C over sine C. You may use whichever form of formula that you would like and prefer, as long as it is appropriate and suitable to be used for the question. There are two situations that will allow us to apply sine rule, which is, first, we are given two angles and one side, or we know the value of two sides and a non-included angle. Okay, next, we also have cosine rule, or also known as the law of cosines. Its formula is C square equal to A square plus B square minus 2 times A times B times cos angle of C. You may rearrange all the formulas accordingly. Okay, all these three formulas actually are the same. What makes it different is the type of angles and sides that you will choose to be inserted into the formula. But please remember, the cosine rule only can be used when we are given either three values of the length of the sides, or we are given with two sides and the included angle. Okay, last but not least, the formula of the area of a triangle, which is 1 over 2 times B times C times sine A. Please make sure the angle that you used in the formula is between the sides chosen. For example, in this formula, the angle is in between side B and side C.
After watching Powtoon, do you remember Danny's situation? Well, let me read the situation again to you. Danny wants to paint the roof of his house. The following diagram is a sketch of the front view of the roof and also includes its value of lengths and angles. Then Danny found out that the wood on one part of the roof is longer than the wood on the other part of the roof. Firstly, the question asks us to calculate the length of the wood on the longer part of the roof and also the distance between both the walls of his house. Also, the question also asks us to calculate the area of the front roof in the shape of a triangle in meters square, which will be painted by Danny. Well, first thing first, we should understand the problem and the situation. Through the situation faced by Danny and the diagram provided, there are several pieces of information that can be obtained. Firstly, we have the value of the length of one side of the roof, which is 15.28 meters. As we have to calculate the length of wood on the longer part, this means that the value calculated will be higher and longer than 15.28 meters. Moreover, through the same diagram, we also have the angles in the roof. One of the angle is 60 degrees, while the other angles is 29.94 degrees. Now all we have to do is to calculate the length of two sides and also the area of the roof, which is shaped in a triangle. Hence, let's help Danny out to solve the problem by using GeoGebra software. That is because the GeoGebra software is very easy to use and effective. Now, let's get started.
So, this is the GeoGebra software. Here, I have copy-paste the diagram that represents Mr. Dennis' roof in advance. From A to B is 15.28 meters. The angle B is 60 degrees, while the angle C is 29.94 degrees. Before that, let's label all of the sides of the triangle to make it easy for us to recognize which sides that we refer to. Okay, sides of AB as a B, sides of BC as A, and sides of AC is C. Okay, now we would like to find the length of AC or C meter here. So how? Well, we will use the sine rule or apply the law of sines to find the value of C. Okay, let's insert the information that we get just now into the formula sines rule to find the length of other part of the roof, which is C meter. Let's increase the size of calculation. Okay. Okay, we want to find C value. So it is divided by sine B, which is 60 degrees, and then equal to B with value 15.28 meter divided by sine C, which is 29.94 degrees. Then the sine 60, we move to the right hand side and multiply it to solve the C. Okay, so let's increase the size of calculation a bit. Okay. Okay, therefore, length of the other part of the roof, which is C, is 26.51 meter. Okay, let's increase the size of calculation a bit. And then here is the answer. Okay then, since we know two angles of the triangle, which is 60 degrees and 29.94 degrees, and we also know that the total interior angle of the triangle is 180 degrees. Then we can find the remaining angles by subtracting 180 minus 60 minus 29.94 degrees. Then we get the angle of A is equal to 90.05 degrees. Okay, let's bigger the size a bit. Okay, then let's label the angle of A in the diagram. Okay, after that, we will find the length of the other side, which is the BC or A side, which is here. Okay, in this case, you are flexible to use either sine rule or cosine rule to find the length of A. But this time around, let's use the cosine rule. Okay, first of all, let's insert all of the information into the cosine rule with the formula A power of 2 equal to B power of 2 plus C power of 2 minus 2 times B times C times cos A. Let's increase the size a bit. Okay, nice. Then let's solve for the value of A. Let's increase the size a bit. Okay. Thus, the distance between the walls of Mr. Danny's house is 30.62 meters. Therefore, that is all for the question A. Now, let's move on to the next question. Okay, for the second question, what is the area of the front roof in the shape of a triangle in meters square, which will be painted by Mr. Danny? If you want to find the area of triangle manually, you just need to insert appropriate value into its place according by referring this formula. Okay? Well, actually, if you are using GeoGebra, you can get the answer instantly and easily with just a few clicks. Okay, to calculate the area of this triangle, which is a polygon of 3 sides, you can just simply increase the opacity of this triangle. And simply click the area button, which is this button. Okay, there you go. You can get the area of this triangle is equal to 202.59 meters squared. So that is the answer. So this is the alternative on solving Mr. Danny's problem. GeoGebra provides various features that will actually help you to solve this problem within a minute. Okay, let's look again the diagram of the roof provided by Mr. Danny. So in order to calculate A side and C side, you can simply choose the distance or length feature and select a line of segments that you want to find the value of. So we will get A side is equal to 30.62 meter and C side equal to 26.51 meter. Okay, moreover, you can also find the remaining angle of the triangle by clicking the angle features and select two line segments, which will give you the angle in between the two lines. Therefore, the remaining angles, which also angle A is equal to 19.05 degree. Okay, last but not least, as requested by the second question, wish to find the area of the roof, we choose the area feature. Okay, and click the closed polygon. Then the triangular area which will be painted by Mr. Danny is 202.59 meters squared. Okay, therefore, we already finished solving Mr. Danny's problem and I hope he likes it.